All right, we're back. This is page 10 of notes 2 of Calc C, and we're talking about Taylor polynomials, and we're doing some problems, and maybe I'll just get going. I might, I don't know. I feel like people will object, but I might just do this whole thing on the calculator. So we have the function. You should have the notes in front of you, or you can open them up on another window or something. Let's see. To try to speed it up a little because it's the same thing over and over, which is like good once you realize that. That's your goal. How do you spell Taylor? There we go. F of x, comma x, and then we need three non-zero terms. I think the the fourth degree probably is what we need. Oh, what? Oh, you know what I need? I need the center. The center is 1. You can't center this at 0 because the function doesn't exist at 0. The first, second, none of the derivatives exist at 0. You can't just center it wherever you feel like it. 4 non-zero terms. So this is 4 non-zero terms because the first term of this series, of this polynomial rather, is x minus 1. So that's 1, 2, 3, 4 terms. So that can be a little weird. And I wish the calculator would put parentheses around the x minus 1 there. And then it would be a little more obvious. Like you have 4 quantity x minus 1s. That's 4 non-zero terms, except I'm supposed to use 3. So great. 3. There we go. That's 3 non-zero terms. So I'm going to say that that's p of x. All right. And then let me delete some stuff. I need to approximate p of 1.8, which is my approximation of the natural log of 1.8. So let's see what we get. We get 0.651, I guess. So actually, I am going to write these. So like, take a breather, write them down. So p of x is equal to x minus 1 minus quantity x minus 1 squared over 2 plus quantity x minus 1 cubed over 3. And then p of 1.8 is approximately the natural log of 1.8. And we get 0.651. And again, the three decimal thing can kill you on these because it is possible to have done them wrong, basically. Like you can get something that's like correct to 5 decimals, but because you rounded to 3, you're gonna get like false when you make your interval. I think that's not gonna happen here, but it could. All right, so how many derivatives did we need to get this? So third power, third derivative. So I need the 4th derivative. So let's find the 4th derivative of f of x. And then I need the maximum of the absolute value of the 4th derivative on the interval from the center, which is 1, to the value we plugged in, which is 1.8. So I'll actually go back and I'll write that one down because this is m. Finding m is like the big thing. This is where you can go a little astray if you're not paying attention. So here we go. So I need the maximum of, so on the interval from 1, which is the center, to 1.8, which I'm plugging in. I could have plugged in 0.8 and then it would be the maximum on 0.8 to 1. It's always the center and the thing you're plugging in the correct order gives you like your interval. We need the 4th derivative, the absolute value of the 4th derivative. Oh my gosh. Which means that we're finding the maximum from 1 to 1.8 of the absolute value of -6 over x to the 4th. So if you think about it, you can work this out without a calculator because, so the absolute value just makes it 6 over x to the 4th. And then 6 divided by x to the 4th is definitely decreasing because the numerator is constant and the denominator is getting bigger, right? So it's definitely decreasing, which means the maximum must occur at the left endpoint. So I'm actually going to use 6 because if I plug in 1, I get the absolute value of -6, which is definitely 6. So this is the value that we're going to use for m. So I'm using this for m. And then I know that my error, the absolute value of the error, is less than or equal to m, so 6, times, we need absolute value around what we're going to write here. This is going to be 1.8, which we're plugging in, minus the center, which is 1, and then to the 4th over 4 factorial. So these 3 things, this, and this, if those aren't the same, you're doing it wrong, like guaranteed. Those have to be the same when you do this. And then this, I'm going to end up calling it ERR on the calculator, but we're going to do that. And then here I'm going to have P of 1.8 minus E less than or equal to F of 1.8 less than or equal to P of 1.8 plus E. Then I'll write that down eventually. Back to the calculator, let's see. So here we go. So these are, like, you want these to be pretty routine. So we're using 6. So let's say is fraction. It's going to be 6 times 1.8 minus 1 is just 0.8. So I'm not going to put in the absolute value. And then 4 factorial. Okay, so not terrible. I mean, errors are usually smaller than that, but we didn't use a lot of terms, so that's okay. And also 1.8 is really far from 1 as far as approximations go. So like you should get a pretty wide range of possible values. So if we do P of 1.8 minus the error, we do P of 1.8 plus the error. So we think it's going to be between 0.548 and 0.753, let's say. Let's see what it is. 0.5, so yeah, it's like right in there. So I'm going to write these down while I'm here. So 0.548 less than or equal to F of 1.8 less than or equal to 0.753. And then F of 1.8 is the natural log of 1.8. So natural log of 1.8 is definitely approximately 0.588, let's say, which puts it definitely in the range. So it worked. Okay, so I know I wasn't showing any of that, and I was just like staring at a calculator, and you were also staring at a calculator, but that's okay because we got it done. So this is a risk. I'm just gonna do the next one in this video because we're here, and I think it'll be like less work. Then I don't know why I'm doing it. It's a risk, right? Because if I completely screw this one up, I'm gonna have to like start over. Great. Here we go. I'm going to the all calculator. I said that last time, and then I like wasn't telling the truth. But let's see. All calculator. F of x is 1 over x. So this could not be centered at 0 because it doesn't exist at 0. So there's no way to center it at 0. So I'm going to do Taylor f of x, comma x. I need 4 non-zero terms. So I'm thinking I only need to go up to the 3rd degree because the original value of the function is not 0. So I'm thinking that'll work. And then it's centered at 1, so that's not optional. You have to put it in. So there you go. Those are non-zero. Let's call that P of x. This one's weird, by the way, because like 1 over x is super easy to evaluate. And so I don't know why I would necessarily be doing this, but I am. I'm going to handwrite this in right now. Well, you should too. Catch up. Let's make sure we're on the same page when at some point we decide to look at what I'm writing. We get this, and then P of 1.3 going to be approximately P of 1.3, 0.763. Okay, so that's my approximation of 1 over 1.3, which, like, why am I approximating it? I don't know. To get the 3rd degree polynomial, I need the 4th. See, this is it. Like, I need to switch over because I can't live with not showing you the perfect way to write this because you need to be writing this the right way. So here we go, breaking my word. All right, here we are, right? So we need the maximum on the interval from the center to what we plugged in. So the center is 1, and we plugged in 1.3. So from 1 to 1.3 of the absolute value of 3rd degree polynomial needs up to the 3rd derivative. So for the error, we're going to need the 4th derivative. So, and these are like always using that, and that I always worry that like communicates the wrong thing. 1 to 1.3. The absolute value of, do I know the 4th derivative? I don't think I did that. All right, I'm going to go back here and just back here, right? So derivative f of x, comma x, 4th derivative. So 24 over x to the 5th. So the same argument as last time, 24 over x to the 5th is a decreasing function, certainly on the interval that we're interested in from 1 to 1.3, which means its maximum is definitely at the left end point. So the maximum is definitely 24. Another option, so we're searching on the interval from 1 to 1.3, which like, I guess, I almost never use this, but we could do like f max of the answer x, and then I think it like takes these arguments. So this tells you the x value where it happens. So it happens at 1, then you gotta go back here and say x equals 1, 24. Why does it tell you the x value when it's called like function max? I don't know, but it does. All right, so then the error, so I'm gonna say the absolute value of the error is less than or equal to 24 times the absolute value, 1.3 minus 1 to the 4th over 4 factorial, and I will store that. So let's do that. So I'm going to go back eventually, but I'm trying to speed this up. Struggling with that. So 1.3 minus 1 is just 0.3. So like, you know, save yourself that calculation. 4 factorial. All right, so the error is like really small, which is good. That just means it will be like really accurate. So if I do p of 0.3? Yeah, p of 1.3, sorry. Ugh. And then minus the error, and then p of 1.3 plus the error. That's our interval. So like our value is like, we're very close. And 0.3 isn't like super close to 1, but I guess it's like a relatively flat function. So like you don't get a lot of range, a lot of potential range in values, maybe, I don't know. What's f of 1.3? Okay, so all that's left to do is write all this down. So I'm gonna go back to the notes and you can watch me do that. You should have already written it down, maybe, potentially, but if you didn't, here we go. I'm gonna look at the calculator while you look at this screen, supposedly. So here I was doing p of 1.3 minus e less than or equal to f of 1.3 less than or equal to p of 1.3 plus e. And we got 0.7, I guess 0.755 less than or equal to f of 1.3 less than or equal to 0.771, I guess 0.771. And then the calculator told me that f of 1.3, which is equal to 1 over 1.3, is approximately 0.769, let's say. And that is in the interval, so it worked. So, I mean, if we did it wrong, you're almost certainly not going to be in the interval, unless you got the error like terribly wrong. If you got the error terribly wrong, it's kind of like nothing you can do to avoid that other than be like, when you get it wrong, you'll be like, I don't know if that went well. And if you feel that way, maybe double check. So there you go. All right, we'll be back in the next one. We got one more page of these. I guess I'm going to do them, even though I feel like at this point I could definitely just like set you free and let you go on these. I'm going to do them anyway, and then I'll be back and do more stuff. So see you there.